on the far side of the moon, and the Chang'e-5 was bringing back samples from the near side of the moon. Were both missions paving the way for the Chang'e-6?
Exactly. So you can see, as we already mentioned, the Chang'e-5 mission, the probe almost have the same configuration compared with the Chang'e-6. So we already get the experience, very, very important experience for the Chang'e-6 mission. And also, as you mentioned, the soft landing. Until today, the Chang'e-4 and its Yu-2 or the Jade Rabbit 2 rover are still the only two spacecraft working on the far side of the moon. So today we conducted another mission. Also, if it can be successful, this will be the first time we get the samples from far side of the moon. You know that this have so much difficulties and challenges. First, you know that you may see my post on WeChat, the photo of the moon. But for me, because I stand on the Earth, so I can only take photos of the near side of the moon. And for the far side of the moon, you can never have that on the Earth. So also the same situation for the ground stations on the Earth. So you can see that on far side of the moon, we don't have any support from the ground stations from here, because we cannot see that. So the only choice for us to utilize the data relay satellite, either use the Qiuqiao Magpie Bridge or the Magpie Bridge 2 data relay satellite. So this is one difficulty. Another one comes from the terrain. You see that the most relative flat regions of the moon is located in the near side of the moon.
Right.
So we call that the lunar mare. For instance, the Sea of Tranquility, the Sea of Imbrium, the Sea of the Ocean of Storms. All these lunar mares located in the near side of the moon. For the far side of the moon, you can sell them.
It's a totally different story.
Totally different terrain, totally different shape.
Unknown territory.
Yeah, some terrain are very, very steep. So it's more risky.
Professor Yang, it's a 30 minutes countdown to the launch mission.
So it is T-minus 30 minutes and counting. Or during this process, already many critical checkings and many steps were conducted. For instance, there are all kinds of subsystems on board our Long March 5 spacecraft. But you know that during the countdown, we will have the checking, examination, confirmation of all subsystems. And so, you can notice already on the big screen in the commander's room, we've already seen the right moment for the ignition.
Yeah.
Well, you can see that during the countdown, we will have all kinds of critical checkings, and each one is critical for us. And also, you may notice that, okay, look, on the launch complex, although all the rotational platforms on the survey tower has already been rotated out, you can see the whole launch vehicle. But still, you may notice there are some very small arms still connected to the launch vehicle.
Right.
So at this moment, we still have the cables, pipes, connected to the launch vehicle. You can still see the white fogs released from the tanks, the fuel tanks on the rocket. So at this moment, we can still use the pipes to pour the propellants into the tanks of the launch vehicle.
Yeah. It's pretty fascinating to think how far humanity has come from the Apollo mission in terms of lunar exploration. It's been more than half a century. And then in recent years, or in the recent decade, we are seeing countries, major players of space missions, returning back to the moon, trying to understand more about this planet. What is the purpose of that? What is driving this passion to go back to the moon?
Well, you know that generally speaking, there are two phases in the lunar exploration of human beings. The first phase comes from since actually speaking 1958 to the year 1976. Yeah. So on the first phase, there are only two players, the U.S. and the former Soviet Union. But you know that this is the era of what we call the moon race or the space race. So this race, in this phase, all the activities are politics driven. So they don't care how much they spend on this program. They just want to get the first, every first. So, but it's not sustainable. When they get their purpose, it cannot be continued because so great investment fund in this program.
Colossally expensive.
Exactly. So they were saying that each time you launch a Saturn V lunar rocket, you exhaust a aircraft carrier. So that is the reason why it's not sustainable. But since 1990s, last century, since this comes the second tide for the lunar exploration, during this phase, all these space capable nations send their probes to the moon. But this time, it's not politics driven. It's just
scientific driven.
Exactly. So just we want to get the scientific research rewards for all of us. So this time is more reasonable and sustainable. And moreover, you see that with the probes of many countries, we already have a very, very important discovery,
right.
The water on the lunar surface. So the water are stored in ice form, in solid form, in the permanent shadow areas, in the North Pole,
South
Pole craters. Exactly. You know that the orbit of the moon is very unique because you know that the equator of the moon is very close to its orbital planes, which means that the different seasons, the direction of the sun does not change much. So the direction of the sun is greatly influenced by the terrain of the lunar surface and also its latitude. So in the polar regions, it's possible to have the permanent shadow areas.
Well, Professor, let's now also hear from a colleague. The Chang'e-6 will also carry equipment from other countries, and one of these is a French instrument which will seek to detect radon gas emitted by the lunar crust. So we're now joined by our colleague. Please tell us more about this equipment and what does France hope to achieve through its cooperation with China? Ross, thanks for joining us. Are you with us?
Yes, hello. France is hoping to contribute to this mission with its DORN Dawn instrument, which is going to be on board to measure radon gas, one of the odorless, colourless, noble gases. Also there, that instrument to look at the transportation of lunar dust around the surface of the moon. This is not the only China-France space cooperation mission that is happening this year. There's also the SVOM, Space Variable Objects Monitor, that is due to launch in June as well. The second China-France joint cooperation after the 2018 launch of a satellite by Paris and Beijing to measure and explore the interactions between the atmosphere and the surface. It shows that these two countries are working together when it comes to the exploration of space. That will be one of the topics on the agenda for when Presidents Xi and Macron meet here in person in Paris next week.
Ross, thank you so much for bringing us that. Now we can see from the live feed that scientists are now undergoing the second comprehensive checkup. Is cooperating. We hope the weather will hold for the success of the launch.
Yeah, we can see that it shows that it's now conducting the second integrated checking of the whole mission, because you know that both the lunar probe and the launch vehicle is so commissioned to ensure that every subsystem goes okay. And also, you know, that's, as I mentioned, you can see, look, don't use the energy of the storage batteries on board our launch vehicle storage battery. So this is also a very critical step for the launch.
Any impact on the launch mission?
Exactly. You see that, so the weather forecasting is, maybe we have to cancel the launch. Also, you know that the light is very hazardous to our launch vehicle. In some cases, we also have to, the salty fog will also be, you know, that's the salty fog on board our spacecraft. So we must consider the influence of these factors.
Yeah, just to minimize all the risks that to return to the moon. What does it mean? Why is this discovery for us to explore further into deeper universe?
You are quite right. You see that, as I mentioned, water. So water is not only drinkable for our astronauts, and not only it's easier for us to make the propellants and make the other things for the deeper space missions. You see that because you know that although the moon is also very big, but the gravity on the moon is only 1/6 of and it can be launched into the orbit, it will be much cheaper to bring that from the Earth. So if we want to go to Mars, if we want to go to the moons of Jupiter, so ambitious missions, if we can utilize, as you mentioned, the resources on the lunar surface, either the soil or the
this material.
Yes, exactly. So with this material, we can make these kind of parts on. So easy to launch these kind of things to the orbit, and it will be, to some extent, it is possible in the future. It will be much easier.
Springboard for us to explore.
Exactly. So, so the moon, that is why it is not only very meaningful, very important on the better understanding of the evolution of the solar system. But
very plain terms, Professor Yang, about the geography of the moon. For example, just to give our moon, even though we have limited knowledge about that part of the planet. For example, we kept mentioning about the and from this angle, we could see clearly that it was still on the launch pad.
Yes. So we have a very what kind of things.
Right.
Just with approaching to the moment of the liftoff, we will, as you mentioned, we will detach the pipes and cables from to the next step. So in this process, we will also have a good monitoring of all the parameters there. But also we have some window payload fairing, which made not from metal. So we can emit a radio wave penetrate the launch the payload fairing. So we also have some receiver near the launch pad to get the signals from the Chang'e-6 probe directly. So we can measure whether the telemetry.
I'd like to share with you some memory from years ago when I was covering the launch of the Chang'e-2 mission. Launch
Exactly.
Center. And one engineer there told me that it looks like the umbilical cord being detached from the launch vehicle. It's like the rocket is a baby and it's ready to go to leave.
Exactly. So what you mentioned is on the 1st of October.
You clearly recall that date, right?
In that day, I was in Prague attending the International Astronautical Congress. You know, that's the second mission of our Chang'e project.
Right.
So very, very impressive. So you know that at that moment, our Wenchang spacecraft in what you mentioned, the Xichang Satellite Launch Center.
Right.
So in Xichang Satellite Launch Center, we have the Long March. That day, what you mentioned, we launched the Chang'e-2 probe with the Long March 3C rocket. With this rocket, we can directly launch the Chang'e-2 probe from the Earth to the translunar orbit.
Right.
So that's the first time we into the translunar orbit.
Now, 15 minutes countdown to the big moment of the launch. Professor, going back to our previous question, we were talking about geography of the moon.
Yep.
Give us, like, we keep mentioning about the far side of the moon, and then there's also of the moon, and then there's the Aitken Basin. What is the relations of these different spots?
Well, you know that the far side of the moon. So the near side of the moon occupy a half hemisphere of the moon, and the far side occupy the other. But you know that the total area 38 million square kilometers. So it's very huge. And you know that what you mentioned, what we call the Long March 6, the sample point will not be the South Pole, but it's in the located inside the South Pole Aitken Basin, because you know that the South Pole, that's the relationship between the different.
And Professor Yang, let's now hear from a colleague from Pakistan. Now from Islamabad. Well, Daniel, good to see you there. We know that Pakistan is sending a payload towards its scientific significance.
I was here 3 months ago in March when students from the Shanghai University had arrived, and the significance about this satellite, the moon in Urdu language, and it has been created in collaboration with the from Shanghai University. They got together and met for the first time in March. We covered the intensive workshops that they had, and it was quite interesting. I spoke to the students. They are the weight is 7 kgs. It will be traveling on the Chang'e-6 probe, and going to be orbiting the moon by itself. It's going to be laid off around 200 to 300 kilometers before it has 2 high definition cameras, and it is going to be taking these pictures of the far side and the dark side of the moon.
Well, Daniel, as you mentioned, this will be the country's maiden moon mission, the IQQ. Certainly there's a lot of expectation. The local scientific community is reacting to this launch.
And the students and the faculty that have been involved in the creation of this satellite, they're very excited. I've spoken to them. They're saying that this is not the first time that Pakistan is collaborating with China, but they say that in nano satellites, this is going to be the first. Are now looking forward to even more sophisticated technology shared by the Chinese counterparts as far as space technology is concerned. So yes, there is a lot of excitement inside this auditorium. It is full to the brim. Hundreds of students of the institute have gathered to witness this historic event.
A historic day for Pakistan, a dream of so many aspiring students to experience.
My childhood. Basically, it looked really fascinated when I look at the moon continuously walking with us. Okay, and I usually
Q satellite designed and developed by Pakistan's Institute of Space, China's Shanghai University, and Pakistan's National Space Agency CubeSat will be the first nano satellite to travel into deep space exploration. It is also the first satellite.
Just want to check in on this live coverage that we're bringing this morning of China's second lunar soil sample return mission. They are expected to bring back about, from what I understand, listening to 3 pounds of soil, 2 kilograms. I think that translates. And it will be the ever return to Earth, because Apollo and the lunar missions there were pulling samples from the what we call the lighted side or the visible side of the moon. The lander has a mass of about 3.8 tons, and the ascent stage that will bring the soil samples back from lunar orbit, and the capsule brings them back to Earth. So, very interesting spacecraft, very interesting mission overall. First soil samples coming from that region of the moon. So we look forward to that launch. At this point, in checking, looks like T0 is on time, about 8 minutes and 13 seconds. The spacecraft is launching from LC-101 at Wenchang Space Launch Site in China. It's launching aboard a long march.
For the launch, and I will be joining the students and the faculty members who have given hours and hours
4 strap-on rockets.
Into the launch that is going to be taking place.
And it'll bring about 32,000 kilograms, that rocket, 32,000 kilograms to LEO. And it is a Long March 5. So I want to double check that. But everything looks to be good right now. And we are looking at an on time, approximately 5:27 Eastern Daylight Time. Just want to thank the CCTV news agency for providing the feed out, so we have the opportunity to share that and educate the public. Also like to thank the subscribers. You guys are awesome. We continue to gain subscribers, and we just ask that you keep watching and sharing those videos and viewing those videos. It all helps us get further out in our reach to contact more people, have more folks be members of the family, and enjoy what we have been able to provide and will hopefully continue to provide. If you're not a subscriber, please check out the channel. A lot to see here. We're up around 150 videos now. Carry a lot of launches, if not the majority that we can. And hopefully this summer, with the cadence coming up, we'll be able to hit some more local stuff, being that we're only about an hour from the Cape Kennedy complex. Look forward to that. Also, if you'd like to help us support the channel and help us pay the bills a little bit around here, we would appreciate that. Any support at all, we would appreciate. You can head out to daviddeliverspace.store, and we have a lot of cool items there that you can purchase. We try to keep things reasonable, and that certainly goes directly to assisting us in maintaining our presence here, our channel, and growing. And as we get prepared to bring the podcast online, that's going to assist us greatly. That'll be a weekly event. There'll be more information on that next probably week or so. So, again, thank you all for coming out today. Appreciate you coming out on an early morning or wherever you are. If you're on GMT, it's coming up on lunchtime for you. So I'll stand by. We're about T-minus just under 5 minutes now. And hopefully watch another great launch and a historic launch with its mission profile, where it's heading and what it is they're hoping it can do. Bring back those samples from the dark side. It sounded kind of ominous and kind of Star Wars-ish. Wasn't meant to be, though. All righty, folks. Enjoy the launch. We'll stand by. We'll get back with you after the broadcast has run through a little bit. Thanks again, and good morning from Florida.
Launch today. So that's a narrow launch window, because the capability of our can provide some design margin for the launch window. So according to its capability and what we need for it, we can have expand. This is a reason why today we can choose the narrow launch window. So it for the launch today. So we can have the tolerance if something wrong happens.
And we understand that the Outer Space Treaty in 1966, 100 countries signed up to this legally binding treaty, which for exploration
exactly.
of space.
So as a space-capable nation, China also signed to be responsible.
3 minutes countdown.
T-minus 3
any,
minutes and counting.
Any announcement, any command from the scientists there, the engineers there.
All the ground staff has
breath.
withdrawn from the launch complex.
Right.
So at this moment, as I mentioned, so there will be withdrawn of the service arms from the previously attached to the launch tower. Right. The cables, the pipe, yes. So it's all on its own. And during this following seconds, we will also transfer the electrics on board our Long March 5 launch vehicle.
Sure. Now, 2 minutes before the launch, we'd like to give our viewers a little bit side of the moon and back, returning lunar soil and rocks to Earth.
Great. That's what I mentioned. The arms will turn from withdrawn from
being
the
detached from the
final
final
cables.
sign that all systems go. The rocket is
detached from the launch vehicle. We also.
And really, at this moment, I'm pretty sure that us and viewers watching this moment are holding their breath. And again, the highlight of this mission is that the Chang'e back to Earth. And if successful, a history-making mission. 1 minute countdown from the launch pad in Wenchang.
You can see the 4 boosters.
50 seconds countdown. Well, certainly this mission, the Earth's formation, its evolution over billions. 30 seconds countdown.
The onboard computer is now in charge of everything.
Right. And certainly will bring you as the rocket blasts off. Final 10 seconds countdown. You're now watching live feed from Wenchang Satellite Launch Center. China's Chang'e-6 mission into the sky. It's all systems go, Professor Yang.
So magnificent. And now the tower is clear. Change the direction.
Right.
And now you can see this is a video captured by the camera mounted on the launch vehicle. Actually, rocket boosters.
Right. Are the cameras infrared?
This is a visible light camera.
Invisible light camera.
Frames of the boosters. Each have 2 rocket engines, YF-100 rocket engines with a thrust more than 120 tons.
Sure.
Ground stations, the voice comes from the reporters of the ground stations. That's the telemetry received normally and the
Now, as we mentioned, this mission will last for 53 days, much longer than the previous mission, the Chang'e 5. It's going to bring back lunar samples from the moon.
Next step will be the separation of the side boosters. We have 4 boosters. 4 seconds.
As we were discussing, Professor Yang, how long would it take for the probe?
The powered descent only lasts for several minutes, less than 10 minutes. But they will on the design of the whole mission profile. Next, we will be seeing the separation of the boosters soon.
Now, even the launch moment was successful. Is a success because every step of the way will be pivotal for the entire mission. Will be the moment that marks the success of the launch.
Yes.
Which part?
The separation of the probe, and also, that's the unfolding of the solar panels.
Solar panels.
Okay, great, beautiful.
Boosters.
Yes, all the 4. The rocket will continue to. And the next critical step will be the separation of the payload fairing.
Right.
In the ascending phase, and its altitude is go higher and higher.
We are now a little over 4 minutes into.
So now it's a flying of the first stage. So as I mentioned, the first stage have 2 rocket engines with liquid hydrogen animation.
3D animation
And
back
this
to
is a
the
video
cameras
from the camera.
installed.
Yeah. Moment we can see the fuselage of the first stage, and as I mentioned, we have 2 rocket engine. Each have a thrust more than 50 tons.
And actually how high is it? How far from Earth? Because we can now see that beautiful view of the Earth.
Yes,
from
we've
the
already. 50 kilometers high, and high enough, as I mentioned, we will conduct the separation of the payload ferry. Our screen, we can see the camera inside the payload ferry. We've already seen the scene inside the payload ferry.
Right, that's a very clear look, a very clear vision of the payload from inside.
So we can see that the Chang'e-6 probe is stored in this payload fairing.
Right.
And next, so we don't need the, as I mentioned, because it's already high enough, we don't need the protection of the 2 pairs.
Mission?
First, we should separate the first stage.
First stage, right.
Yeah, first stage. Sorry, the separation of the first stage.
Followed by the second stage, ignition. Right.
Yeah. It's a video from the board on the rocket. Now you can see the beautiful Earth and the curve of the horizon of the Earth.
Very romantic and beautiful journey.
Yeah, what
to
you
the
see
moon.
now is just above the Pacific Ocean.
Right. This it consists of 11 phases. Every detail, every single action.
So although the core stage, as I mentioned, of the first stage is much smaller than its full boost energy. Great, the flight is normal according to the voice reported by the ground station.
Professor, the spacecraft consists of 4 separate components.
Exactly.
There's an orbiter launch. The Chang'e-6 will travel to the moon and enter lunar orbit, and the lander and the ascender orbiter and re-entry module stay in orbit.
Yeah. The combination of the orbiter and the returner will stay.
The ascender and the lander will touch down at
And
the far
collect
side of the moon
samples.
and collect samples to the re-entry module.
Great. The first stage has separated.
First stage separation. So my understanding is that the ascender will blast back in orbit and transfer the sample to the re-entry module.
Look, you can see the first stage separate and going far behind the second stage.
Another
Near the rocket engines, so we can see the working. So on the right of the screen, we can see the video camera mounted on the rear part of our second stage. So we can monitor the working of the rocket engines. This rocket engine is called YF-75D. The liquid oxygen as the propellant. It will work much longer, although the thrust. It will ignite twice. So with the first ignition, it will burn several minutes. So at the moment, 10 minutes after launch, it will shut down first.
Yeah.
So at this moment, it will float in this parking orbit for about 10 minutes, which causes
before it touches down on the moon, after it goes into orbit, one very important step is to soft landing
exactly.
on the moon.
So you know that there are two steps. The first is vehicle from the translunar orbit to the circumlunar orbit. As you mentioned, the combination of the lander and ascender with combination of the from about 1700 meters per second to 0. Also, the altitude from about 100 kilometers to 0.
This relay satellite.
Yes.
2 in
Yep.
Mandarin and Magpie Bridge 2 in English to the far side of the moon.
Absolutely.
And that's why we need that learn more about what's going on there and also receive data.
Well,
from
you know,
the action
as you
there.
mentioned, the Magpie Bridge 2 or the 鹊桥2 data relay satellite. But I should emphasize the 鹊桥2, our probe, the lander on the lunar surface with our ground stations, as a bridge to conduct the communication. But also, it is very important for us to measure the precise the coordinate of the landing point and also ascending phase of the ascender. You know that the basic requirement for rendezvous and docking is with the same orbital plane of the orbiter.
Sure.
So that's really important.
So does the Magpie Bridge visual images
Measure
from the far side
of the okay, we can see we hear the voice of the ground commander that that will last about 10 more minutes.
10 more minutes.
For any probe to the moon, we must have or conduct insertion near the equator. But you know, although you know that Hainan province is the most southern province of China,
Right.
but still it's not located on the equator. So that is when the first shutdown of the second stage completed, we will have a coast phase about 10 more minutes, and then we ignite again.
Magpie Bridge 2, does it provide data or visual images?
Speaking, the camera mounted on the lander, whole sampling procedure, and then the signals of these videos will transfer first to it to the Earth.
Is there a time delay, I would imagine?
The time delay is only 1 second, you can
a little
ignite
more than
that.
a second.
Yeah, because you know that it's too far from the Earth. The distance is
To the probe, does the Magpie Bridge 2 also do the job?
it cannot directly send the command to the probe to the lander directly. So now we can still, you know, that at this moment with our Tianlian data relay satellite. So you can see we can still send the video. This is a 3D animation, but it is based on the real data we get from the. So it's just fly above the Pacific Ocean.
Right.
So when it reaches the equator, it will ignite again.
Yeah. Before we get to the technical details, let's talk about the different types of landing or different types of lunar exploration.
Yep.
Because there are which part is the most technically challenging?
Absolutely, the sample return will be the most challenging one, like this one. Program in 3 very simple Chinese words, 绕落回.
Right.
绕 means in English, and you know that we conducted this by the Chang'e 1 probe and the and hui means sample return. So we conducted with Chang'e 5. So you see, for each one step, we also need to do the things on the previous step. For instance, you must have the orbiting, and for the sample return, you must have
Of the
exactly.
previous one.
So we master the key technologies one by one.
So
fourth phase of our lunar exploration program. So for this program, we will set up or build a permanent base on the lunar surface called the International Lunar Station. So it is an international cooperation with other countries. So today already have many countries involved in this program. And you know that's in the fourth phase of our lunar exploration, we only have the Chang'e-7 and the Chang'e-8 probes landed in the South Pole regions of the Moon. So they will form the most essential or the basic configuration of our research station. So we can see that in the commanding or flight control hall of the Wenchang Space Launch Site, we can see the time of the total flight duration. Exactly. So this time, we also can see from this 3D animation, which is driven by the real data, we can see the real attitude and also the position of our combination of the Chang'e-6 probe and the second stage of the Long March 5.
yeah, and of course these scientific data are crucial for ground control command to monitor the status of this spacecraft.
So as I mentioned, the spacecraft need to fly from Wenchang Space Launch Center, spacecraft launch site to the equator. So it do need several minutes.
Sure. So again, our plan to build a lunar research base.
Exactly.
Would it be on the far side of the moon?
It still depends on which is the final chosen position. But absolutely, it will near the South Pole, whether it will on the near side or on the far side of the moon. But still, you know that we've already talked about the Qiuqiao-2 data relay satellite. It is very interesting that the Qiuqiao-2 chose a quite different orbit comparing with its successor, the Qiuqiao-1. So you know that the Qiuqiao-1 located in what we call the halo orbit, very close to what we call the Earth-Moon L2 point, which is far from the moon, about actually speaking about 70,000 kilometers above the moon. But this time we choose a high elliptical orbit circle around the moon for this Qiuqiao-2, because with this design, the orbit will be much closer to the lander, so it can get more high-rate communication for its lander.
And again, this is the time. This is the time of the flight duration.
Yes. So the next critical step will be the reignition of the second stage.
Reignition of the second stage.
Also named as the translunar orbit insertion. So at this moment, the combination of the spacecraft are in what we call a parking orbit.
Parking orbit.
Parking orbit. So the altitude of this orbit is usually only about 170 kilometers to about 200 kilometers in altitude. So it's not very high from the Earth, but still it is outside the atmosphere. So it is possible we fly in this orbit in a very short period, for instance, this time in about 10 minutes, to fly to the equator.
You mentioned just now the long-term goal of China's lunar exploration program is to build the scientific research base on the moon's surface. But it couldn't stop just there, because China has a bigger goal of sending people, astronauts, onto the moon by 2030.
Yes, so we both have robotic missions and manned missions to the moon. So each mission are very important and very necessary for Earth. For the robotic missions, you have more choices because the budget is much lower than the manned missions. For instance, for lunar probe or sending return mission, we only use the Long March 5 mission, Long March 5 probe, Long March 5 rocket, which can send about more than 8 tons to payload to the moon. But for a manned mission, we at least need the capability more than 40 tons. You can see how the difference is. And you see that, so each one is necessary. For the robotic missions, you can have wider choice of in which point you get the samples and in which point you conduct the research. But for the manned missions, you know that we can brought our experts to the moon. For instance, during the Apollo 17 missions, a scientist, Mr. Harrison Schmitt, were brought to the moon. You know that he's a scientist and he conducts all kinds of very complex operations on the lunar surface. So this is very meaningful and very necessary.
But of course, he must have undergone intense training in order to become
Absolutely.
an astronaut.
Yeah.
Right. Right. So this race back to the moon is going on in different countries.
I don't
We know-
recognize it as a race. You see that we China developed our space technology, conduct our lunar program, not only the robotic program or the manned lunar program, according to our needs to promote our high technology. To have the space technology, to develop these technologies, benefit our daily life, benefit our progress of the society. So we don't have the risk of with other countries. Whether the other country will be earlier than us or behind us, we don't care about that.
Yeah, China has always maintained its position that the exploration of space is peaceful and the benefits should be shared by all of humanity.
Exactly. And you see that for the human being, the moon has other very important meanings. You know that today the energy is a great problem for the human being, for the sustainable development for the human being in the future. But you see there are helium-3, very sufficient helium-3 resources on the lunar surface. Although today it is still too early to talk about collecting the helium-3
for,
at this
for the
stage.
Earth's benefit, but the resources, the reserves there could power Earth for centuries.
Maybe next century, maybe later. So if in the future, theoretically speaking, it is possible for Earth to master the technology of controlled fusion power. If we can get or master the technology of controlled fusion power, it will be the completely green energy resources for the human being. And you know that, as you mentioned, the helium-3 on the lunar surface can be used for thousands of years for human beings. So that is the reason why the lunar exploration is so meaningful today.
And that could certainly help address the climate and energy crises that we are facing today on Earth.
But I still should emphasize that's still too early to talk about this now.
It's a blueprint. It's a long-term goal.
Exactly. It's a vision.
Yeah, it's a vision.
So about 5 minutes left for the second ignition of the second stage. So we will conduct the lunar orbit insertion very soon. So you may notice at this coast face, we also have the control. You can see that although it is not a real video stream, but the 3D animation, as I mentioned, is driven by the real data, by the real parameters. So you can see that the attitude or the direction of the combination of the spacecraft is still very, very stable because we have the attitude control engines on board our second stage of the Long March 5.
Sure. We're now about 24 minutes into this mission, the Chang'e-6. This is a milestone mission as it will mark the first time that a spacecraft will make a landing, hopefully, a soft landing on the far side of the moon and bring samples back.
We have a measure to adjust the duration of the coast phase to have different choices of the launch window. So this is also a key technology we've already mastered several years before. And with this help, we can extend the launch window. And as I mentioned, you know, as we've already discussed, you may remember just now, we already discussed the influence of the weather. There are all kinds of things that can influence the possibility of a launch. So to extend the launch window, we must master this technology.
Right. So for humanity to further explore the moon, it's not only for us to get a better understanding of the planet, but also for us to go deeper into the universe.
Yes.
For example, maybe perhaps one day in the future, the moon could be used as a launch pad.
Yes, quite right.
For our journey to Mars.
Yes, and according to the many experts, it will be cheap now. The human being has not mastered the necessary technologies colonizing Mars. But I always support that the human being now a permanent base on the Martian surface. It is very meaningful and also very important for us. It will have a sustainable or a low-cost transportation system between the Earth, either on the Martian surface or on the Earth. On see the scene in
They all look very
the flight
relieved,
control center.
relaxed, and that's certainly a good sign.
So
Risky
now we are very
part.
close to the second ignition.
Right. You do have a long-term space there. You are thinking about building a camp, building a research base on Mars.
Yes, like that we done in Antarctica region. But to do this, you know that the cost of the transportation between the Earth and Mars is extremely expensive now. So for this purpose. So the first thing step, maybe like just what SpaceX have already done, we should also master the technology of companies, and the private companies in China is now developing this technology.
Scientists and engineers at the ground.
Both for the ignition, the re-ignition.
Yeah. As we said, every minor step of the way is pivotal for the success of the entire mission.
Yep.
Second stage ignition, the second
Re-ignition.
time. Re-ignition.
Okay, for several minutes.
Second stage boosts for second time.
So lunar orbit insertion. You know that the parking orbit, the velocity is about 7.8. So there is a great gap between these two velocities. So that second ignition, just near the equator. So we utilize the second stage to conduct the second burn to have the transfer.
And amateurs are like, keeping their passions is the
Curiosity, I believe it is human nature.
Yeah.
But for all human beings. And also, I should emphasize that to study, to explore destiny of human being. You know that why we conducted so much missions measure, we can have a more precise prediction of the fate. Billion years, the sun will become a red, and at that moment, the Earth is not habitable for human being.
Yeah.
So what will happen in the future?
Nothing is impossible. Hundreds of years ago, when scientists phenomenal telescope, and we were able to have the first, the Chang'e-6 mission is bringing with it a payload from Italy. So much humanity has, made leaps forward in our exploration,
a very powerful function to take photos on the lunar orbit.
Yeah.
So I believe very helpful for us. Although it is impossible for such things on the far side of the moon, but with the orbiters we can do this. And even lunar reconnaissance orbiter, it can even take the pictures of the trail of the rovers on the lunar surface.
So thinking about the long term, by 2030, and the U.S. has its Artemis program going on at the same time.
Yes, you know that Miss Wang Yaping, the first space teacher of China, also the first one, he hopes to walk on the moon in the future. So first, Yang Liwei has already fulfilled the first millennium dream of the Chinese people, and I believe that. As you mentioned, we will have the plan to be scheduled before 2030, before the end of 2030, to have our first more powerful launch vehicle, even much more powerful than this Long March 5 rocket.
Right. Earlier on than an unmanned mission, is it because it has to bring with it the life-supporting materials like food, for example, to really keep our astronauts alive and functioning well on the moon?
You know that we can have a comparison of our Shenzhou spaceship is more than 8 tons. But you know the difference between Shenzhou for the spaceship to the moon, it must have much greater capability to change its velocity comparing with a very huge fuel tank and have so much propellant. You know that the moon than the Earth. So when approaching the moon, we must deaccelerate or brake. Go back to the Earth. All these procedures need a lot of propellant. So that is the reason why it's even only not include the lander, even the spaceship itself is the much more powerful rocket. Actually speaking, a Long March 10 for this process.
It's heavy.
So still the second stage is burning. After it is burned off, the probe, the combination, so it's already shut down, as I mentioned.
Already shut down.
Yeah.
And after that, we'll be awaiting the panel to open up.
Yeah.
Well, Professor Yang, I know you are really fantasize when you look at the moon from Earth.
Wow, you know, that get more details of the lunar surface. I enjoy this, and also many of my foreign friends with the optical systems. So this is how I can be the necessary skills for the for study the optical system. Is a 3D animation based, as I mentioned, driven by the real data. Okay, beautiful.
And that was the separation
So
of
now
the
you can
rocket
see the video
and the
is the rear part of the Chang'e part of the probe. Is the biggest part is the orbiter.
So this certainly marks another important step of the rocket.
Yes.
And
so
the
so this is also
spacecraft.
another critical step, and then will be independently several
Right.
days later.
Yeah.
So we need the unfolding of the two pairs of solar panels.
And until these two sets of solar panels are opened up, that will mark the success.
Orbit, because you know that only it is accurate enough, we can have the possibility to conduct the successive procedures.
And I also want to talk about China's space station. Showcased on the CSS.
Conduct international cooperation. So today we already have the joint experiments with other countries and visiting of the foreign astronaut to our new space station. So
You know what, Professor Yang, when I see the scientists, engineers taking scientists there.
are already being acquired. So as I mentioned, the parameters is also very critical for our mission.
Sure. Has the
No, at this moment it's still too far from the Magpie Bridge 2. So at this moment it still have the communication 1 series tracking ships on the Pacific Ocean. So that means that the most risky part has already passed for the launch.
We're talking and having some small chat over there.
Yeah.
It's a rewarding moment for the science. It really is something that we're all looking forward to.
Yeah. You can see it's already more than half an hour now. So that is a very important feature for us, very long.
And now let's hear McCorin, former senior advisor for science and exploration at the European Space. Now, as we are both watching for, as we're both waiting for that big moment, the announcement of the success of the launch mission, what aspects of Chang'e-6 lunar mission are you most
Far side of the moon and bring samples back? It's very different. Side of the moon, the piece of the moon we see all the time because of the way the moon is locked to the rotation of the Earth. The moon was struck by these very large impactors, by asteroids. History, billions of years ago, was that something that happened very quickly in one big bunch of impacts, or was it about the history of our solar system that way? So that's really exciting. But let me also say, you know, to getting to this point now, half an hour into the mission, it seems to be going extremely well.
And as you mentioned, formation, the evolution of the moon over a span of billions of years, and China cooperation in space for a long time. What do you make of the cooperation between?
Well, I think it's a good thing. I've been talking to some of my colleagues this morning, ESA colleagues who are out there in China at the launch, and hopefully I'll chat to them a little bit later on, and hopefully they will have but bringing those instruments on board to do science, of course, is the main goal of this kind of cooperation, is to share the science with Japan, and we collaborate with China. We also have a mission which should be launched in the next year or so called SMART, investigating the magnetic field of the Earth, and that's an important aspect which is linked to atmosphere, is something we want to study in more detail. So we just saw the launch. That will be a European launcher with a European Chinese payload and mission to the moon. So I think that this scientific collaboration is, of course, very political issues in the background here. But as a scientist, collaboration go forward.
Mark, let me also ask you this. I could see, and I'm pretty sure that you're familiar with the Chinese culture. And you must also know that the Chang'e is named after this legendary Chinese goddess. Do you also share this dream of lunar exploration, this passion, and of course renewed ambition to explore the moon?
I think it's something, of course, that's fascinated me throughout many of the Apollo astronauts. I've been on tour with Buzz Aldrin, for example, who was on that very first mission with Neil Armstrong to the surface of the moon. And to see that come back now in recent years, of course, there is an element partly, again, of this geopolitical aspect where players in this game. And there's also this question of exploitation that your guest there spoke about a bit earlier on, which is driving the science, but the possibility of looking at them as a resource is another thing. I'm a little bit skeptical about making it a fully commercial thing. The resources as well, that it shouldn't be a free-for-all, that everybody can go and just get rich till we've investigated it properly scientifically. So I think it's a very interesting time. I mean, if I'm Zhuo, if I remember correctly from one of my trips to China. And so I'm also very interested in inspiration that space can bring. And then the collaboration also encourages, I think, is something we need to reflect back to Earth, collaborating to solve some of the challenges that were addressed earlier in your program, fusion and how we solve the energy crisis. That we're only going to survive on this planet collaboration, and we're not going to go and live on other planets very soon. So I think that's the important strategy, is an exemplar for that.
Of course, we are seeing competition at different degree, but it doesn't have to be that way. I mean, the discovery, the learning. Thank you so much, Mark, for sharing with us your insights.
Thank you.
Well, the Chang'e-6 is part of China's international cooperation in space. A French instrument mounted on the lander. CCTV's Natalie Carney talked to Pierre-Yves Meslin, a planetary scientist who invented the instrument.
For years, planetary scientist Pierre-Yves has been working on the first ever French instrument to be deployed to the surface of the moon.
Dynamics of the lunar atmosphere, but also to study the physical and thermal properties of the lunar soil where those gases are produced.
Radon, which is produced in lunar rocks and when emitted migrates to colder areas of the lunar environment.
If we radon, we will be able to better understand also the migration of other volatile species, such as water, that can migrate to the cold polar regions and then form ices that is a prime interest for the future Chang'e-7, Chang'e-8, other international agencies.
Romain Martin is the mechanical architect of the Dorn.
So here we are shining. The radon is going to be captured by the detectors, two detectors forming a telescope. The front one will be seen by the instrument.
The project team says time was the biggest challenge when it came to the Dorn's development.
The project started early 2020, right before COVID time, and we delivered last summer. That is super short for us. So having that we develop and that is going to the far side of the moon, it's really exciting for us. We are going to be part of a mission that has a really technological fate. So it's a great honor to be part of it.
University of Geoscience in Beijing to make the project happen.
This is the first time that France and China are collaborating on solar system exploration. First, they helped us interacting with the engineers from the spacecraft team at CAST. They also helped us negotiate last August. They helped us mount instrument onto the spacecraft. I think we have established a relationship of trust and also friendship.
And continue harnessing the benefits of international collaboration in discovering the and Toulouse, France.
Well, international cooperation is certainly this mission, and our colleague Mark, right there, he was talking about turning this idea from exploration of the moon to exploitation of the moon. This first mover advantage, for example, whoever gets it will have a say on how to explore the moon and maybe exploration of the planet.
Well, that have a smooth cooperation with other Apollo missions are the legacy not only of the United States but recognize it as the legacy of all human beings, but outwardly there. So we should protect that. It is the human being, not only the United States. So we will protect that. Resources are the resources of. So it is the right moment because that the transportation between the Earth and the Moon is already very practical. So it is the right moment for of the Moon. So to this extent, it is the exploitation.
And we are now almost 50 minutes into this mission, a little over.
At this moment, is the Chang'e probe is orbiting the Earth in shadow. It has 3 pairs of solar panels.
Located on the orbiter,
the returner,
lander.
and the lander.
Right,
yes,
and the
exactly.
returner as well.
So, but before the just in this stage, we will unfold 2 pairs of them: the solar panels on board the orbiter and the one in the lander. Yes. Because this moment they are a combination of 4 spacecrafts, but when it already entered the circumlunar orbit, it will separate
into
and
2
become
parts.
Independent parts.
Right. The ascender and the lander will be in one part, and the returner and the orbiter
will the other part. So
right.
The one combination becomes 2 combinations. The unfolding of solar panels means that we can get a continuous power supply from the sun.
Right. And during these 53 days of the Chang'e-6 mission, our scientists on Earth, on the ground, will also be keeping precise communication with our probe.
Actually speaking, when it is in the lunar orbit, we can utilize our ground stations. But when it is on the surface of the far side of the Moon, we can only depend on our Qiao data relay satellites. And you see that, as you mentioned, that in the 4th phase of our lunar exploration program, actually speaking, in the Chang'e-8 mission, we will demonstrate the right technologies to utilize the resources on the lunar surface. So the on-site resource utilization is already on its way. So we are preparing for the exploration of the lunar resources.
And as we mentioned just now, Professor Yang, the sampling procedure will involve two parts. One is drilling and the other part is scooping. The solar panels are being unfolded on the orbiter. That's right, and that is...
So this is the first step. This is shown by the, as I mentioned, the real telemetry data received from the vehicle itself. Although it's only a 3D animation, but it can represent the real status of the spacecraft.
Now, can we say at this stage that the probe, the spacecraft, will be on its own?
Actually speaking, it's already on its own during the separation between the rocket and itself. But still, that at that moment, because it's in the shadow area of the Earth, so it can only use the electricity in the storage batteries inside the probe.
Right.
So at this moment, with the unfolding of the solar panels, it can have, as I mentioned, a continuous power supply with solar energy.
What is the difference of the lunar soil retrieved from drilling and the scooping procedures?
Yes, good question. You know that when we get the samples by drilling, we can have a better understanding of the evolution of the moon, because many information were under the ground, under the surface of the moon. So if we can get more deeper under the surface, this can get many information. And for those on the surface, that for billions of years, for more than 4 billion of years, the influence of the sun and the surrounding environment also is very important for us to study. So that the regolith, the rock on the surface of the moon, already lie there for billions of years. So with the, as you mentioned, the scooping of the samples, we can also have the information in this area.
So on the near side of the moon, because there is direct sunlight, the objects or the materials for than that from the far side of the moon?
As I mentioned, that the direction of latitude on the moon, the lunar night lasts for 14 days comparing with the Earth, and also the same as the daytime on the moon. But for the position places, maybe they have a very, very, very long-term sunshine. So that is the reason in the long-term sunshine area, low latitude regions, the temperature can be below 200 and extremely cold night. So it is easy period. Right. So that is the reason, as I mentioned, why the South Pole is so important for human beings. So the thermal control is a challenging factor for us.
Years, how deep are
Well, that there are very, very small craters maybe created every day on the lunar surface, but still, at this moment, it's still. But that during the history, according to the study of astronomers, hundreds of kilometers wide. So that is the reason, as we've already discussed, the South Pole Aitken Basin, far side of the moon. As I mentioned, the diameter is more than 1 kilometers, very, very huge. And also, that one interesting thing is that these kind of inside the moon to the surface also
mantle
or even in the core.
Things and evidence of volcanic activities on the moon.
Volcanic activities last for billions of years. So we've already get the very helpful samples during our Chang'e mountain, the Mount Ramco in the Ocean of Storms, which is the landing site of the Chang'e-5, is much younger than other places on the moon. So that is the reason.
The near side of the moon is being exhibited to...
yes, in the National Museum.
At the National Museum Evolution of the Moon.
Actually speaking, that we already have released different batches of this sample. One important thing, or very, very important, interesting thing is that some of the scientists need to return the sample back. Because that there are two generally speaking, there are two categories of study. One will exhaust we will lose the sample after study. But with some other measures, we can have no any loss. So with these measures, after study, the scientists need to return the samples back to the China Academy of Science. So this is very interesting. And you know that for Earth, we already find some material that never exists on the Earth.
Right.
So it is known as the Chang'e stone. So this is maybe the third material discovered.
Right, and as the Chang'e-6 mission aims to sample retrieve from the far side of the moon, the probe will go through many stages before it brings home precious lunar soil.
The Chang'e-6 mission has some 11 flight stages. First, it is launched into orbit by the Long March 5 carrier rocket. Then it enters a rush to the moon process. When nearing the moon, it will pull the brake and enter the lunar orbit. That's called perilune braking process. Then the probe files in the lunar orbit. The lander and the ascender form a combination, and the orbiter and returner form another combination. The landing-ascending combination will touch down on the far side of the moon to carry out lunar sampling task, while the orbit-return combination will continue to fly. The sampling on the far side of the moon includes both drilling and surface sampling methods, and scientific exploration on the far side of the moon will also be carried out. After the sampling is completed, the ascender carrying the collected lunar soil will take off from the far side of the moon to dock with the orbit return combination. The moon samples will be handed over to the returner. When the orbit return combination comes near the Earth, the returning capsule will separate. In a hopping move, the returner will re-enter the Earth's atmosphere and land in Siziwangqi, Inner Mongolia.
So let's give a review of China's lunar exploration program, Professor Yang. From 2007 to 2020, we've seen the evolution from Chang'e 1 to Chang'e 5. What are some of the experiences or lessons learned from these missions?
Well, let's digress them one by one.
Yeah.
So as I mentioned, we have already accomplished the 3 phases of our lunar exploration program. So the first stage, we will master the technology of orbiting the moon. So with Chang'e 1 probe launched in 2007, we mastered this technology. But it is very interesting. You know that at that moment, we don't have much experience on this. So we choose a very interesting trajectory that do not directly go to the moon. So the Long March 3A rocket only launched the Chang'e 1 probe to the geosynchronous transfer orbit, which already have great experience on this. And then with the engines on board the Chang'e 1 probe, reading its apogee, finally it goes to the moon. And then we have the very successful lunar orbit insertion and become an orbiter of the moon. And we take so much pictures, and the first time we got the 3D images of the whole moon. First time.
Sure.
And then after the mission, the Chang'e 1 probe controlled an impact on the sea of fertility on the lunar surface. So this is the first spacecraft object of China to reach another celestial body. And then, you know that in 2010, as you mentioned during the live coverage, at that moment I was in Prague, and we conducted the second mission. And it is a preparation for the landing mission, because you know that during this mission, we choose a direct transfer by the Long March 3C rocket, powerful than the Long March 3A, and directly send our Chang'e 2 probe to the translunar orbit. And then it choose a much lower orbit than the first one. And it also demonstrates the necessary technologies to lower down to the Rainbow Bay to preparation for the landing mission. And also, after the major task, the Chang'e 2 leave the circumlunar orbit and go to 1.5 million away from the Earth, called the Sun-Earth Libration Point 2. And then go deeper into the solar system and taking pictures of the Tortoise asteroid. Very, very interesting. And you know that in 2013, we conducted the Chang'e 3 soft landing mission in the Mare Imbrium, or the Sea of Rain, near the Rainbow Bay area. So this is the first soft landing of China. And several years after, maybe in 2018 or 2019, we conducted the Chang'e 4 mission. And just before that, we also have two very important missions. One is the launch of the Magpie Bridge 1, or the Qiao data relay sat. Another one is what we called, we also, I remember that we have an interview here. It's called the Long March 5 T1 flight test, which is to test the technology necessary for the returner to go back to the Earth with a much higher speed, more than 11 kilometers per second. Long March 5 mission. And then in 2020, we launched the Long March 5 and the Chang'e 5 probe. And then today, we have the sample return mission from the far side of the moon.
Flyby, the hard landing, and the soft landing. Of course, soft landing involves more precision. And of course,
just within these years, we have been seeing that. You see, that is the reason why it is so difficult. You know that landing, you must deaccelerate your very high speed to zero within a very short several minutes. And also decode any of your subsystems, such as the wrong measure of your position, or the error in your measure of your attitude, your direction, and also other error in your measurement, and also the error in mission. So that is the reason why today only a few countries can conduct a soft landing on the lunar surface. Moreover, you know that just several months before, the United mission, because there is a leakage of the probe. The Odysseus mission of the United States, they also suffered, and it's not a very full successful missions for these countries. So you can see how difficult it is to have a complete soft landing. You know that during history, Soviet Union conducted 27 soft landing attempts, but Surveyor program. The Surveyor program have 7 attempts to solve success.
And of course, this time it's different in the sense that we are landing. I mean, the Chang'e-6, the probe will be landing on the moon and be retrieving samples. And the landing part is always the most breathtaking part.
As we've already discussed, the terrain, the shape of the moon is completely different from the near side, except for the mare, there do not have much flat areas on the far side of the moon. Moreover, you cannot choose a place comfortable for you. You also need to consider about the meanings or the returns in scientific research. We've chosen is not so flat and have very deep shapes on the and also, although we already have the soft landing on the Chang'e 4 mission, but still it is very challenging for us to.
Well, the moon has always been an object of wonder, and humans continue to be fascinated by the moon despite setting.
You and I know what our planet Earth's soil looks like. It's composed of minerals, organic material, water, and microorganisms that allows plants. Flowers thrive on the moon's soil. Lunar soil is a product of the weathering of moon surface, also another factor for the rock's disintegration. There's no oxygen, water, or organisms that can make lunar soil fertile. Lunar soil does, however, breccia, bonded agglomerates, and various silicates. Without any living elements, it remains a familiar but mysterious body. And even if lunar soil isn't fertile soil, many are wondering why scientists wish to study it.
So did that cause a renewed interest in the moon?
Not only can be drinkable by our astronauts, but also can be used to produce propellants, either to produce liquid hydrogen. You know that why the moon is so unique. It is the closest celestial body to accelerate the object from the lunar surface to orbit. So that you can imagine that will be much more rotation can develop to a certain era. So something on the lunar surface and brought it to the outer space, that will be cheaper than produce that on the Earth and bring to outer space. Although it is more than 300 analysis of the scientists, it is very interesting. If we want to reach the geosynchronous stationary orbit, it is easier, not from the Earth. So you can see how what we call the moon economy stand. Because you know that we will maybe in the future we can have more practical and technology on the lunar surface. So manufacturing on the lunar surface is also possible. So as we already did, so we can get other materials such, you know that the lunar soil is rich of oxygen. So it is easier for us to, but today as you get the methane or water or other things. So why the water is so important? Because although you know the surface of moon, so that means that these together with the water on some asteroid will be very useful for Earth. Not to bring them back to the Earth, it's meaningless, but to have, as I mentioned, already been successfully unfolded.
Right, and this is certainly an important stage. So let's go back to our earlier discussion, the discovery of water, this very valuable natural resource to support life and power our future. I am confident that
exactly. So
there
that is the
water.
most important discovery of the Chandrayaan-1 mission conducted by my colleagues and friends from East.
Mission, the latest one is the Chang'e-6. It's a history-making mission as it will be landing on the far side of the moon and return with lunar samples. We are now more than an hour into the mission. Now there comes the official announcement.
Yes.
Officials, experts, and the comrades. According to the Long March 5 data and the data and report from Beijing Aerospace Control Center, the Chang'e-6 probe has accurately entered the preset orbit and solar panel unfolded successfully and functioning well. Now I declare the launch mission a complete success.
Bravo.
Big congratulations to our scientists and engineers and people who've involved in this history-making mission. And as you said, Professor Yang, the screen really turned from blue to red, and that's a tradition from the Flight Control Center here on the Earth. No matter how far our spacecrafts travel or how important the mission is, it always comes to this final moment of the announcement of the success of the mission.
Of the whole mission. Well, yesterday I just sent a text message to Mr. Wu Weiren, the chief designer of the whole China's lunar exploration program, expressed my best wish to